Hello there, week 6 P4. I'm going to do another example. So for this case, we are going to determine the normal shear stresses after the element has been rotated 25 degrees clockwise, and the next one is 30 degrees anti-clockwise. Okay, so 25 degrees clockwise rotation. So let's start with A. So you still need, so this is the Mohr circle that we're going to work on, okay, which we have done on the previous example. So now it's going to rotate clockwise by 25 degrees. So if you can rotate from the Y down here, okay, so rotate clockwise 25 degrees. So 25 degrees clockwise rotation, right? So you can rotate it this way, right? So this is the clockwise rotation by 25 degrees. Okay, so this is about 25 degrees. Okay, so this is a clockwise rotation 25. So because you rotate from Y, you're going to call this point over here, right, this surface over here, Y 25. Okay, and directly if you're going to rotate the element clockwise from X, so you'll be rotating this way clockwise also, right? So this angle of rotation is also known as your X25. So we're going to call the surface Y25 and X25. Okay, so what we have from the previous example is we found our principal angle, that's 23.2, and then the radius of the circle is 37.079. so now we're going to rotate on Mohr circle. Okay, Mohr circle is going to be we're going to rotate, okay, rotate from point Y by twice times by 25. So it's going to be a rotation of 50 degrees, and we're going to rotate in a clockwise direction from point Y. Okay, so Y, we're going to rotate 50 degrees. So 50 degrees rotation, it will bring us somewhere around here. Okay, somewhere around here. So that is our 50. I'm trying to do apologize. So we'll try to rotate to get our 50. Okay, so this 50 rotation which I've marked, okay, so this is the 50 rotation, right? So this is the 50. Okay, now 50 from where? Is 50 is rotated from here to here. Okay, so this is 50 degrees clockwise. Okay, clockwise direction. So this point over here that we have just done, this point over there, this is going to be our Y25. Okay, and then if you start from point X, so this will be our X25. Okay, so this is our X25 point. So we have to calculate our location of our Y25. So basically I'm going to sketch out my triangles. Okay, so we are going to find what is our stress state at Y25. Okay, so we know that our center, our circle, which I've labeled 0, so this is on our is -5 and 0. Then we have our point down here, right? This over here. Okay, our is a Y25 point. So I'm going to sketch a straight line. So you guys know what I'm drawing, yes? Our Y25. And then we know that our radius, okay, radius is equal to 38.079. That's our radius, which is this distance, which is the distance from here to here, right? So that is our radius, and this radius is our R, and we have calculated it before. Is equal to 38.079 megapascal. So we need to find our normal stress Y25 and our shear stress Y25 location. Okay, so the first thing we have to resolve is we have to find this angle known as beta. Okay, so beta angle is equal to this angle over here, right? Is this angle over here, which we have found it to be 23.2, right? So 23.2 plus by 50, so this will be equal to 23.2 plus by 50 is equal to 73.2 degrees. So you set up this angle already. So the first thing, so the easiest to find is your stress Y25. Okay, your shear stress Y25, so it's equal to 38.079 sine of 73.2. Why sine? Because we want to find, so this height over here, right? This is your stress Y25, and the distance, right? So that is your stress Y25. Okay. And then the distance from here to here, that is your shear, sorry, what am I doing? That's your shear Y25, and that is on over here is your normal stress Y25. Okay, so this will be equal to 38.07 times by sine 73.2 is equal to 36.454 megapascal. So I do it again, 38.079 times by sine 73.2. Okay, so your shear, so your normal stress Y25 is equal to, so you have to start from -5, right? Because the original has -5 down here. Okay, so this is related to here, and it's going towards the left hand side, right? Your Y25 normal stress Y20, so it's minus cos 73.2. So this is equal to, or with the radius 38.079 cos 73.2. So cos 73.2 times by 38.079, so it is equal to minus 16, okay, which is about right, minus 16 megapascal, right? So we know that the normal stress, the shear stress Y25 is equal to the shear stress X25, and this is also equal to, sorry, what we have indicated down here is, so we know our at Y25, I do apologize, at Y25, right, our normal stress is equal to 36.454, and our shear stress, what am I doing today? Sorry. Our normal stress Y25 is at minus 16 megapascal, and our shear Y25 is also equal to 36.454 megapascal. 454 megapascal. So from here, you also can find your stress X25, because of the orientation is directly opposite over here, right, on your X25. So your X25 is basically minus 5 plus, because it's on the right hand side. Okay, it's on the right hand side, 38.079 cos 73.2. So 38.079 times by cos 73.2 minus 5, so it's equal to 6.006, or 6 megapascal. Okay, so you look at here, it's in the positive side. And then always take note that the shear Y25 is going to be equal to the shear X25, and this is equal to 36.454 megapascal. So your X25, what you have found is that the normal stress X25 is equal to 6 megapascal in positive, and then your shear X25 is now equal to 36.454 megapascal. Okay, so in this we have to construct, our element now. Okay, so our element is going to rotate clockwise. Alright, it's going to rotate clockwise. Now this is where you have to pay a lot of attention. We have to rotate clockwise. Okay, so I'll draw my transformation first. Okay, our original. Okay, this is our original. On the element, clockwise 25 degrees. So we're going to rotate clockwise 25 degrees. So there's 25. I'm going to change the color. Okay, so this is our X25. Copy, paste, then I'm going to rotate. Okay, so this is our clockwise rotation, 25 degrees. Then we construct our element. We're going to draw our element now. So this is how our element look like now, right? So we know, based on what we see from the original, how we rotate. So we know that this surface over here, right, this surface over here is your Y25 line, and this over here is your X25. So you look at your values. Let's do the normal stress. The Y25 is going to be minus 16 compression, so you're going to have a compression of minus 16 MPa, and then on the 25 is going to, the X25 is going to have a tensile of 6 megapascal. Now the trick is the shear stress. We know the shear stress is equal to 36.454. So you look at point X, Y25, right? Y25 is over here. The shear stress rotation is clockwise, and below is what? Anti-clockwise. So Y25 rotation is what? Clockwise. So for the element to rotate clockwise, the shear stress has to be coming where? Down here. So for the element to rotate what? Clockwise. Okay. So if you look at X25, right? If you look at X25, is in the element rotation is what? Anti-clockwise. So we know that element rotating anti-clockwise, this arrow has to be from here. So this is where you write in 36.454 megapascal. So this is the stress state. Okay, so this is what we call, right from here, this is what we call the state of stress. Okay, this is what they call the state of stress. Okay, I'm going to work on another example based on the same element, but now we're going to rotate it differently. Okay, so I'm going to copy same thing. Okay, so I'm going to copy this part also. Okay, we're going to go to the next slide. Same question, but I'm going to do the next part. Okay, so we're going to do when it's going to rotate 30 degrees. Okay, 30 degrees. Counter clockwise. Okay, so I'm going to erase this. Okay, I'm going to erase this. Okay, so now we are going to rotate counterclockwise by 30 degrees. Okay, counterclockwise, anti-clockwise rotation. So anti-clockwise rotation. So you can do anti-clockwise rotation about here. Okay, about here. Right, you can rotate anti-clockwise by 30 degrees. Right. So this is anti-clockwise by 30 degrees, or you can also rotate this way, anti-clockwise by 30 degrees also. So anti-clockwise rotation by anti-degree. Okay, so for this case, I will call this your Y30 anti-clockwise. Okay, so at this point now, this is my Y30 anti-clockwise, and this also will be my X30 anti-clockwise. Okay, rotation. So from here, I'm going to copy the same Mohr circle. Okay, information are still the same. The principal the principal plane, I need all this information. Right, so this information is still needed. Okay, Mohr circle, the original Mohr circle still look the same. I'm going to take from here. And copy. Come back here. I'm going to paste. Okay. Okay, so as I said, the Mohr circle is now, but the rotation is going to be different now. So now the rotation is 30, so it's going to be 60 degrees. Okay, so now from Y to, so this is 60, right? So I'm going to now, so the orientation is different now. So from here, okay, so this point over here now will define my Y30, and this over here will be my X30, right? So the rotation is 30, but you have to rotate 60. So basically is the rotation from here to here is now 60 degrees. Likewise from here to here is also 60 degrees. Okay, so from here now we have to calculate our angle from here to here, which is our beta angle. Now you realize that the formulas change slightly, right? So our beta angle now, right? So beta angle is now equal to 60 minus by 23.2 degrees, right? So 60 minus 23.2 is equal to 36.8. So we have found this. The procedure is still the same. We are going to find the stress. We're going to find what is happening at Y30. So from here, we can specify that the shear stress Y30 is equal to 38.087. So 38.079, and now sine of 36.8 degrees. So 38.079 times by sine 36.8. So now it is equal to minus 22.81. Oh, sorry, 22.81 degrees. Right. Then your normal stress Y30 is equal to minus 5. It's going towards the what? Left hand side, minus 38.079 cos 36.8. Okay, so this will be equal to minus 5 minus by 36.079 times by cos 36.8. Okay, so this is 30.491. Okay, 30.491. So on your X, or on your normal stress, is equal to 35. Okay, it's equal to minus 35.491 megapascal. So this is, so next we have to find our X30. So the X30, the shear stress X30 is equal to Y30 is the same. So it's equal to sorry, it's not in degrees, it's in megapascal. Okay, so this is also equal to 22.81 megapascal, and then your normal stress 30 is equal to minus 5 plus by 30.491. Same explanation like before. Minus 5 plus by 30.491, so it's equal to 25 positive 25.491 megapascal. Okay, so now you have all these values. Now it's time to rotate your elements again. Okay, so I'm going to have our original. Right, so this is our original. Right, so what we're going to do now is, now on the element we're going to rotate 30 degrees counterclockwise. Okay, 30 degrees. So before that the element was rotated clockwise, so now it's counterclockwise 30 degrees. So it's going to rotate in a counterclockwise direction by 30 degrees. Right, so from here, this is our rotation now. Okay, our new axis. And then we're going to rotate. So this will generate a rotation anti-clockwise by 30 degrees. We draw in our element now. Right, this is how our element will look like now. And then if we look at our original surface, so this is known as your Y30, and this is your what, X30. Right, so if I bring it here, so your X30 is parallel to this surface over here. This is the same line parallel, and Y30 parallel to, so this is your Y30. So you can put in, so from here you look at your value of your Y30, so it's compression. Okay, it's compression by minus 35.491 megapascal, and then your X30 is going through tension by 25.491 megapascal. Now let's look at the shear. We know the shear over here now is going to generate a what? On the Y30 is going to generate a anti-clockwise. So the arrow has to be what? Coming down anti-clockwise. Okay, so this will be your 22.81. And on the X30, you look at your X30, it should generate a what? A clockwise direction. Yes or no? So clockwise direction. So it becomes what? Negative shear configuration, as you can see down here. Okay, so this is your 22.81 megapascal. Okay, so this is how you can solve a problem like this by orientating your elements. So for assignment number 3, question number 2, based on completion, same thing, you have to rotate about 25 degrees and 10 degrees counterclockwise. Thank you so much. That's all for my week 6